Welcome to my third class of Fourier series. In the second class, we already discussed general construction of Fourier transform formula over the interval a comma a plus 2l. Based on general formula for Fourier series, we consider two cases. Case number 1 in the interval 0 comma 2l. Case number 2 is minus l to plus l. Based on that, is already discussed how to identify, how to proceed, how to construct Fourier series based on first case and also based on the second case. Now, continuation of the second case. In this class, I am going to discuss some more subcases. Now, whenever the given function, we want to construct the Fourier series in the corresponding interval. Suppose the interval is in the form of minus L to plus L. In such cases, not necessary to find out A0, AN and BN. Then here, so we are going to consider two more subcases. Before going to consider two more subcases, one of the definite integral we discussed already in the first class of Fourier series based on prerequisite integration of minus a to a f of x dx with respect to x. There are equal to two cases. One is twice of is equal to what? Actually, two cases twice of 0 to a f of x with respect to x. The condition is if f of x is an even function. Suppose f of x is an odd function, what happens? This integral value is 0. If f of x is an odd function, is an odd function. This result we already discussed in first class of Fourier series. Based on this result, we are going to take two subcases. Only the thing is, where given interval is in the form of minus L to plus L. The first subcase is subcase 1, or you take A, if f of x is an even function. Is an even function over the interval minus L to plus L. Before construct the Fourier series, first you have to verify what happened A0, AN and BN. What is our A0 formula in the second case? 1 by L minus L to L f of x dx. But the function is even function. From the definite integral property, f of x is an even function, minus a to a. Similarly, minus L to L can be written as twice of, we get 2 by L, 0 to L, f of x with respect to x. And also, I have to find out AN. What is my AN is 1 by L minus L to L, f of x cos nx, cos of nx by L with respect to x. Here observe carefully, f of x is an even function, we already assumed. Cosine functions are even, you already know that. Plus into plus is what actually plus, our plus is even function, minus is an odd function. Now here, product of two even functions must be even. Again from the definite integral property, this can be written as twice of 0 to L, 1 by L, 0 to L f of x cos of n pi x by L with respect to x. With respect to x. Yeah. Now, then I have to write properly for this. Yeah. Now, f of x cos of, not cos, sine actually. Sorry, cos of n pi x by L with respect to x. Because cosine functions are even, we already assume that f of x is even. Product of two even function must be even. Similarly, I have to verify what happened Bn. What is the original form Bn is 1 by L minus L to L f of x into sine of n pi x by L with respect to x. But we already assume this is an even function, but sine functions are odd function. You know that plus into minus is what actually? Minus. Here minus is odd function. Even is plus is even. Okay. Product of even into odd is odd function. From the definite integral property, what happens? The b1 value must be 0. See, whenever the function in the interval, in the second case for minus L to L, the supposed function is an even function, no need I to find out which value, bn value. We have to write directly bn is 0. Okay. Now, in the next step, if f of x is an even function over the interval minus L to L, what is our actual Fourier series formula after the simplification? A naught by 2 plus summation n ranging from 1 to infinity a n cos of n pi x by L, where what is a naught formula? 2 by L. Only we are considered half of the given interval. Not necessary to take entire interval minus LTL. Is reduce the calculation also. Time consumption compared to the original formula for case 2 to this is less. F of x dx, and then an is 2 by L, 0 to L, f of x cos of n pi x by L with respect to x. Now move to the next subcase. What's the subcase is? If suppose f of x is an odd function in the interval minus L to plus L. Subcase B. If f of x is an odd function over minus L to plus L. Now here, first you take original formula for a naught, an and bn. What is the formula for function over the interval minus L to L? A naught formula is 1 by L. Just now we taken here, no? Here you know that here this formula same thing. A naught 1 by L minus L to L f of x dx. Now observe carefully here. Now observe now here. Here you already know that f of x, we assume that is an odd function. F of x is an odd from the definite integral property. What happened? This must be 0. Therefore, a naught must be 0. Similarly, an is 1 by L minus L to plus L f of x cos of n pi x by L with respect to x or dx. In this case, now observe carefully, f of x is even function. Sorry, f of x, what we are consider, f of x is an odd function. Yeah. Okay. It's odd, but sign functions are even. Product of minus into plus is minus, therefore this is odd function. From the definite integral property, what we get actually is 0. From the definite integral property, the value of this integral is 0. Now, move to next bn value. What is the bn here? Bn is 1 by L, yeah, minus L to plus L, 1 by L, minus L to plus L, f of x to sine of n pi x by L with respect to x. We already assume if f of x is an odd function, sine functions are odd. You know that product of two odd function minus into minus is plus. Product of two odd function is an even function from the definite integral property. This property, you know that from the definite integral property, what we get actually, this must be equal to twice of 2 by L, 0 to L, f of x sine of n pi x by L with respect to x. For suppose the given function is odd function in the given interval minus L to L, no need I to find out all a naught, a naught, n, b, n. Just you find out bn. Therefore, now See, a modified formula for suppose f of x is an odd function in the given function is an odd function in the interval in the second case minus L2 plus L. What is my formula for construction of Fourier series? Only a summation of n ranging from 1 to infinity Bn sine of n pi x by L, where what is my Bn formula? 2 by L 0 to L f of x sine of n pi x by L with respect to x. Now observe carefully here, a little bit zoom out to it now, then easy to see entire thing here. Now in the case 2, what is case 2 is f of x defined on the interval minus L to L. We already discussed this formula. But not necessary whenever function is defined in minus L to L, it's not necessary to go to find out always a naught, an and bn. With the help of this definite integral property, suppose in the second case the given interval is minus L to L, the function is an even function, which value 0, bn is 0, only I have to find out a naught and an, but not necessary to take entire integral, we have to take half of the integral 0 to L. Otherwise you take minus L to 0, but usually for our comfortable we are choosing 0 to L. But keep in mind you have to write twice of that. And also suppose the function is odd function, what are the values are 0, a naught and an is 0, only is remaining bn, then we get very easily the construction of Fourier series, only I have to find out bn. Instead of that, apply case 2 directly. Suppose function is odd function, find out a naught, an and bn, definitely a naught and an is 0. They simply are wasting a time. That's why you have to explain the student in the first class itself, construction of Fourier series, how to construct the series. Keep in mind these two cases, only a sub cases allowed for the interval must be in the form of minus L to plus L. Because most of the students they are doing mistake. For example, I am going to take one example here. For example, f of x is x square over the interval 0, 3. Oh, x square is an even function. I go for what about only I have to find out a naught, an, no need I have to find out bn. Wrong actually. Keep in mind, if you want to go for even or odd, I told in my first class, always define in negative to positive limit. First you observe the limit. Based on that to decide I go for case 1 or case 2. Whenever interval is in the form of case 2, then we permits to go for even case and odd case. Here we can't go for even or odd case. Suppose f of x is equal to x into sin x over the interval minus pi to pi. Yeah, the interval is in the form of minus L to L. Now before going to construct the Fourier series, we have a right to go for even or odd. First you have to verify even or odd. How to verify even or odd? Replace x by minus x minus sine of minus x. Sine of minus theta is minus sin theta, minus into minus plus, we get x sin x. The given function is an even function. Now which value 0? Pn is 0. While construction of Fourier series, you have to find out a naught and an using the formula 2 by L, 0 to L. Now, again I'm going to explaining this. Before going to consider even or odd definition, first you observe the limit. Suppose limit is in the form of minus L to L, then I have to go for even or odd. And also another one point, the students they are going to confuse. Suppose the function is defined in the interval, say in the interval f of x is defined in the interval minus L to plus L. No, we have to verify even or odd, but we can't say that always is an even or odd. For example, f of x is equal to x plus x square over the interval minus pi to plus pi. Yeah, is in the form of second case. Is in the form of second case. Now I go for even or odd. You replace it x by minus x. What we get? Minus x is minus x whole square is plus x. What we get? Minus x plus x square is not equal to f of x. Suppose I have to take minus sign outside, what happen? X minus x square. This is also not equal to minus of f of x. Observe here the given function is in the form of second case, but function is not even, not odd. Therefore, such type of function is treated as neither even nor odd function. In such cases, we are going to construct a Fourier series using second case formula only. in the interval minus a to plus l. What's the second case formula? And this is our second case formula. Now, using this formula, we have to construct the Fourier series. Now, before move to the next step, again I'm going to repeat, if you want to go for any cases, first you have to observe the limit. Based on that, you go for first case or second case. Whenever is involved belongs to the second case, then only have a rights to move for even or odd. Otherwise, you don't go for even or odd. After that, before you construct the Fourier series, please take care to taking a value of L. Suppose in the first case, what is our interval is 0 to 2L. How to find out the value of the L is equate to upper limit of the given interval to, for example, upper limit the given into 0 to 3 equate to upper limit of 2L, first case, then simplify that, automatically we get 3 by 2. Then similarly, whenever the given interval is in the form of second case, in such cases, how to take the value of L is equate to again upper limit of the second case to given interval of the upper limit, then we get the value of L. This is a way to find out the value of L. You must and should have to take care taking the value of L, because then is very important tool to construct the Fourier series. Before move to the next step, I'm going to write a flow chart. What are things I discussed from previous class to this class. In the first previous class, what I first I considered general case. Yeah, general case. General method to construction of Fourier series. What is your general, if you want to write clearly for this, what is the general formula for Fourier series? Beginning we consider over the interval a comma a plus 2l. I'm recalling once again for your formula for Fourier series, entire thing what we discussed last class and present class, okay? Okay, fine. Now here, what is the general formula for Fourier series? Suppose function is defined, f of x is defined over an interval a comma a plus 2l. What is your Fourier series formula? What is your Fourier series formula here? The Fourier series, this is nothing but general. Okay. What is the Fourier series formula for this case is what actually? F of x equals a naught by 2 plus summation n ranging from 1 to infinity a n cos of n pi x by L, and also summation for n ranging from 1 to infinity b n sin of n pi x by L. Where what are the formulas for finding a naught, a n and b n for Fourier quotients? 1 by L. The limit is a to a plus 2l f of x dx, and then a n formula is 1 by L a to a plus 2l f of x cos of n pi x by L with respect to x. This is a very important. The rest, once you clear the rest of the thing, suppose we are confident with integration, how to evaluate using UV rule. That's next further steps are very easy. F of x into sine of n pi x by L with respect to x. This is a formula for, suppose we are defining the function f of x is defined over the interval a comma a plus 2l. This is a general. General I divided into what about that two cases. Yeah. The first case is, now I have to take a is what actually a is 0, and then here a is equal to minus l. Therefore, now what happened? F of x is defined over the interval 0 comma 2l. Here f of x is defined over the interval minus l to plus l. Okay, fine. In the next step, what is the Fourier series for this f of x? Fourier series for the function defined over the interval 0 to 2L, same formula for what we written for f of x defined over the interval. The only thing is instead of a to a plus 2L finding a naught n and bn, we are going to take 0 to 2L. What's the formula for this? F of x is equal to a naught by 2 plus summation n ranging from 1 to infinity an cos of n pi x by L plus summation n ranging from 1 to infinity bn sin of n pi x by L. Okay, fine. Where? What's the formula for A naught? A naught is what? 1 by L, 0 to 2L, f of x dx. Then what is our an formula? 1 by L, 0 to 2L, f of x cos of n pi x by L with respect to writing a naught, n and bn is very easy. Once you construct the Fourier series based on the given interval, while writing a naught, just you take the given interval 1 by L 0 to f of x dx. While taking an and bn, instead of an you take f of x, instead of bn is f of x. Write the integral 0 to 2L 1 by L. That gives us the formula for an and bn. 1 by L 0 to 2L f of x sin of n pi x by L with respect to x. Okay. Now, suppose a is equal to minus L. How to construct the Fourier series for this function here? I'm going to take the Fourier series for this function is nothing but, better I to put a bifurcation line for this. Okay. Now, Fourier series what actually f of x is equal to a naught by 2 plus summation n ranging from 1 to infinity an cos of n pi x by L plus summation n ranging from 1 to infinity bn sin of n pi x by L, where what is my a naught formula? A naught formula is what actually? 1 by L minus L2 plus L f of x dx. What is my an formula? Is nothing but 1 by L minus L to L f of x cos of n pi x by L with respect to x. Similarly, the Bn formula for this is, Bn is what actually? Bn is equal to 1 by L minus L to L f of x sin of n pi x by L with respect to x. These things you already know that. Okay. In the next step, suppose the function is defined in negative to positive limits. There we have two subcases. What are the two subcases we consider based on this? Two subcases. Yeah. I'm recalling all the entire thing in the flow chart. Okay. Now here subcase here f of x is then even. Here f of x is an odd. Okay. Suppose f of x is an even function. What is our Fourier series expansion? F of x is equal to which value 0? We have to write it that also. Here which value 0? Bn is 0. Here a naught is 0 and an is equal to 0. Then we have to construct the Fourier series for this a naught by 2 plus summation n ranging from 1 to infinity an cos of n pi x by L, where a naught, what is a naught? 2 by L, 0 to L, f of x dx. What is an formula is 2 by L, 0 to L, f of x cos of n pi x by L with respect n pi x by L with respect to x. Well, come to this side. What is a construction of Fourier series? Only having which value? Bn. Therefore, for n ranging from 1 to infinity, Bn sin of n pi x by L, where Bn is what? Twice of 1 by L, 0 to L, f of x sin of n pi x by L with respect to x. Now, once you clear this flow chart, the rest of the thing is very, very easy. Now I'm showing entire thing in one screen. Observe carefully for this part. Yeah. Now observe carefully this. Uh, yeah. Now in the general, what is my general cases actually? Observe carefully. Now general is what f of x is in the interval a comma a plus 2n. You return what is the formula for f of x. So based on general case, not necessary to take always this formula. For student benefit, student convenient, we are considered two cases. You observe any problem, either belongs to the first case or maybe belongs to the second case. Put a0, 0 to 2l. What's another case is minus l to plus l. 0 to 12, whenever start from 0, you can't go for even or odd. Keep in mind, most of the students, they're doing mistake here. They worried about function. Don't worry about the function. First, you observe the interval. Interval is in the form of start from 0. You go for first case. There we don't have even or odd. There is no chance. I have to find out a naught, an and bn. The interval is 0 to 2l. How to take the value of L here? Equate to upper limit of the first case is 2L equal to corresponding upper limit of the problem. Simplify that, we get the value of L. Suppose A is equal to minus L means the given interval get what minus L to plus L. Suppose function is defined in minus A to A or minus L to L. In such cases, we have two cases. F of x is an even function, f of x is an odd function. In even function, Bn is 0 using definite integral property. Only we are constructing Fourier series based on A0 and An, and also writing A0 and An formula 2 by L 0 to L, not necessary to take entire limit, only have to evaluate half of the interval of the given interval that gives us same answer if you want to construct using case 2 f of x minus L2 plus L. We get same thing. Suppose function is odd, directly I have to write a0 and an is 0, then immediately we get a very simple expression for the Fourier series. Only I have to find out bn. While finding bn also, 2 by L 0 to L f of x sin of n pi x by L with respect to x. Now, only based on the interval, I have to decide. This is a flow chart for the Fourier series. Once you clear these steps, next is very, very easy. See, general case, based on the two cases. This case, there is no option. Suppose this case, you have two options. Function is even or maybe odd. Some exceptional case, even though the function is defined in negative to positive limit, now, function may be neither even or odd. In such cases, where there is no alternative. Fraction second, we know that function is even or odd. You go for second case. A function is defined over the interval minus L to L. Based on that, I have to find out A naught, An and Bn and then I have to construct the Fourier series. This is nothing but the flow chart of the construction of Fourier series. Now, once you keep this flow chart, you write in one sheet and keep it along with that while solving a problem, then you don't have a confuse. Now, before going to the next step, now the another one or two things you have to discuss here. Okay. The thing is, suppose sometimes we get most of the note, most of the case we get this cos of n pi. Yeah, n is a positive integer only because our an or bn summation range from what? 1 to infinity in the Fourier series. Therefore, n is a positive integer. N is a positive integer means only we get two cases, n may be even, n may be odd. What is cos pi value? Cos pi is minus 1. What is cos 2 pi value? Plus 1. Observe carefully, even case is 1, odd case is minus. Therefore, whenever we get cos n pi while solving a problem in Fourier series, we are going to take generally minus 1 to the power of n for n is equal to 1, 2, 3. We get same thing. Now put n is equal to 1. Cos pi minus 1. Put n is equal to 2. Cos 2 pi is 1. Similarly, cos of 2n pi. Cos n pi is minus 1 to the power of n. Therefore, cos of 2n pi instead of n, what we have? 2n. Now, even multiple of n is n may be even, n may be odd, become a even value. What is this value? Is 1. Whenever we get cos of 2n pi, we are going to write straightly 1. Similarly, sin n pi. What is sin pi value? Sin pi value is 0. What is sin 2 pi value? 0. Therefore, n may be even, n may be odd, sin n pi is 0 for n is equal to 1, 2, 3. And also you know that sin 0. What is sin 0 is 0. These are the things we get while solving a problem frequently. Cos 0. What is cos 0 is 1. And then also what is cos of minus theta? Cos of minus theta is cos theta. What is sin of minus theta? Is what actually? Minus sin theta. And also you have to know the formula for transformation formula for 2 sin A sin B, 2 cos A cos B, 2 sin A cos B, 2 cos A sin B. These are the transformation formula. You know that. Whenever having product of two functions while doing integration, better have to convert sum or difference of the function. You already know that where in the Laplace transform. Even though you must and should have to write it in any one of the sheet. 2 sin A sin B using cos of A plus B and cos of A minus B. What we get actually? Cos of A minus B minus cos of A plus B, because cos of A plus B is cos A cos B minus sin A sin B. I want sin A sin B, therefore minus. The opposite of this means what is 2 cos A cos B is cos of A plus B. We just have to take same, write it same form, then easy to remember. The middle sign must be a positive. That's all. Cos of A plus, cos of A minus B plus cos of A plus B. Because we want to what actually? Cos of 2 cos A cos B. Cos of A minus B plus cos of A plus B. Similarly, you write down 2 sin A cos B formula using sin of A plus B, sin of A minus B is nothing but sin of A plus B plus sin of A minus B. So 2 cos A sin B is what actually? Sin of A plus B minus sin of A minus B. You must and should have to remember this formula while solving problem is very, very important. And also, most of the students while doing a problem, they are going to confuse here, especially for cos of n pi by 2. Cos of n pi by 2. See, what n is what actually? For n is equal to 1, 2, 3. Because we are talking about summation is 1 to infinity. Therefore, n is equal to 1, 2, 3, etc. Now, here observe carefully. Put n is equal to 1. What is cos pi by 2? Cos pi by 2 is 0. Put n is equal to 2. Cos of 2 cancel, cos pi is minus 1. Put n is equal to 3. Cos of 3 pi by 2. What we get actually? 0. Put n is equal to 4. Put n is equal to 4, what happened? 2 pi. 4 pi by 2, what we get? 2 pi. Cos 2 pi is 1. Now this shows that most of the students, they are going to doing mistake here. Whenever get a cos n pi by 2, they are writing 0. You can't write 0, it's depending on the value of n. N may be even, n may be odd. Even though even or odd, you see in the odd cases what happens? 0 if n is odd. Okay. Plus or minus 1. You can't say 1 plus 1 or minus 1 if n is even. It's depending upon the particular even value. If n is even. See, in even case, first case we get minus 1. In n is equal to 4, we get plus 1. N is equal to 6, we get minus 1. Therefore, please try to understand that cos of n pi by 2, if you want to write once again clearly, cos of n pi by 2 value is what actually? 0 if n is odd. Plus or minus 1 if n is even. Similarly, sin of n pi by 2. Most of the student is doing mistake for writing sin of n pi by 2. They are writing the value is 1. Now you can't write the value is 1. I'll explain here. What is sin? Put n is equal to 1. For n is equal to 1, 2, 3. Because our summation is ranging from in Fourier series 1 to infinity. Sin of, put n is equal to sin of pi by 2. What is sin of pi by 2 is 1. Put n is equal to 2. Sin of 2 pi by 2. 2 cancel, sin pi is 0. Put n is equal to 3. Sin of 3 pi by 2 is minus 1. Here what happened in odd cases, we get plus or minus. Ulta of cos of n pi by 2. Even cases are 0. Therefore, sin of n pi by 2 value is 1 plus or minus 1 if n is odd. 0 if n is even. You must and should have to remember this. We can't write any value, definite value for cos n pi by 2, sin pi by 2 in the range 1 to infinity is depending upon the particular value of n. Now this much is clear. The next, while solving in next class, I'm taking some problem how to construct the Fourier series. Then very easy to construct the Fourier series in the corresponding interval. Thank you very much for listening my talk. I'll come and meet in the next class based on some problem how to construct in the Fourier series.